Okay, so this is the first video in chapter 20. Chapter 20 discusses carboxylic acids and their derivatives. So first of all, what is that? Well, you should know at this point a carboxylic acid. So it's going to be a carbonyl bonded to an OH group. Carbonyl is electron withdrawing, as we've talked about, and that's going to have the effect of making that H quite acidic. Okay, so in terms of organic acids, carboxylic acids are about as acidic as it gets, right? So in nature, in biochemistry, in living organisms, you can't have sulfuric acid running around. You can have carboxylic acids. These are going to have a pKa somewhere in the ballpark of 4 to 5. They can go lower depending on what R is, but normally it's going to be between 4 and 5. All right, so if you lose a proton off a carboxylic acid, you get what's called a carboxylate. All right, and if you protonate the carboxylate, you get the carboxylic acid. So what's a carboxylic acid derivative? Well, a carboxylic acid derivative is going to be a molecule that's in the same oxidation state as a carboxylic acid. So this X atom here is going to be a heteroatom. Oxygen, nitrogen, chlorine. You see a whole list of them over here. Right, so the carbonyl carbon in a carboxylic acid derivative has 3 bonds to heteroatoms. So X can't be a carbon or a hydrogen. That carbon's got to have 3 bonds to a heteroatom. Right, carboxylic acid, you got 2 bonds to O, another bond to O, 3 bonds to O. Same in a carboxylate. So let's take these. So this is an acid chloride, the top one. This is a carboxylic acid derivative, right? 3 bonds to, we've replaced the OH with a chlorine. We'll talk about how to do that later on. Carbonyl's bonded to a chlorine, that's 3 bonds from the carbonyl carbon to heteroatoms. The acid chloride is the most reactive of the carboxylic acid derivatives in terms of addition to the nucleophile. So we say it's less stable to hydrolysis. So it's the fastest hydrolysis. And hydrolysis is the conversion of an acid chloride derivative back to a carboxylic acid. Okay, so this can be done either with acid, so you can take any of these carboxylic acid derivatives, turn them into the carboxylic acid by treating with aqueous acid. Okay, so you can do this for an acid chloride just by, you don't even need the acid, you just need water. All right, an acid chloride mixed with water very quickly gives you a carboxylic acid. On the other hand, a nitrile or an amide, you basically have to reflux it for like 24 hours, right? You have to really pound on these down here. So the lower you go on this diagram, the more stable the molecule is to hydrolysis. So you get the slowest hydrolysis down here at the end. Okay, so again, hydrolysis, you're going to treat a carboxylic acid derivative with aqueous acid, that'll give you a carboxylic acid, or you could treat the carboxylic acid derivative with aqueous base, and that'll give you a carboxylate, right? If there's a base here, you're not going to have an acidic proton in the product. And then you get this, these two are in equilibrium. So add an acid, take away an acid. So we have an acid chloride, that's the easiest to hydrolyze. Then we have what's called an anhydride. So you basically merge 2 carboxylic acids and pull water out. So you pull water out, that's an anhydride. Let's skip one. This one that you've seen before, carbonyl bonded to an OR group, right? This is kind of the ether analogy to an alcohol. So if the OH turns into an OR, we call that an ester, carboxylic ester. Then if we have an SR there, this is a thioester. All right, thioester is a little less stable than an ester. And then, I guess we have the amide. All right, we'll have to talk about amides a little more. This is an AMIDE, not an AINE. And this nitrogen pushes electron density into the carbonyl. We get a resonance structure that for an amide is a really significant contributor. Right? The carbon-nitrogen bond has enough double bond character in an amide that the two groups on the nitrogen and the group on the carbonyl and the O are all coplanar. So this really looks like a carbon-nitrogen double bond. And then at the end, we've also talked about these. You have a nitrile. Okay, so that's carboxylic acids and their derivatives.